In this video we're going to take a look at the dynamics operator called force. Force is great because it allows us to create effects like wind and gravity in TP without having to use a space warp. And we can also, of course, save that into a black box to make a self-contained system. Let's go ahead and get started. We'll create a couple rules here. We're going to use a black box from the M3D generator called Born Vol. This creates particles in a volume. We're going to go ahead up here and create a big box. Set the dimensions of that box to be 120 units cubed, and we're going to modify his pivots and put him at the origin. And here in the second rule, we're going to name this rule force, and in force we're going to modify the all group that we've created. Come up to dynamics, let's grab a force. You can see it only needs a particle in order to be valid. If you do not specify the position or direction, the position will be 0, 0, 0, and the direction will be 0, 0, 1, so straight up in Z. Let's go ahead and take a look. Let's set our position. We want to pick this box to born into. Go ahead and create those particles. And for now, let's actually double the amount of particles. Let's use 1,000 particles. And you can see right away, because this force is taking effect, that it's kind of pushing those particles up in that positive Z direction. Let's go ahead and take a look at the force parameters. He's got a strength value. This is a strength per second. Most max space warps like gravity and wind are usually on the order of 10 to 100 per second. And this is actually also in world units, so it will move one particle, one max unit in 1 second. Let's go ahead and change that to 10, get a little more kick out of it. And you can see it's also got a variation. That's just going to use this 10 as the maximum and kind of feather that down. Okay, let's change that variation back. We'll get into the decay in just a second. Let's take a look at the different types. We've got direct, which is kind of a linear force. It's just going to be pushing in one direction. We also have a sphere, which is going to emanate from a center point. That's what the position is used for. Sphere is able to use the decay. We could go ahead and set it at 50, and so 50 units away from that position, only the particles within that distance are going to be affected, and the force value is going to be faded from the center point out to that distance. So there's some fall off. Okay. Next up, let's go ahead and take off that decay. Next we have cylinder type, and cylinder is basically going to, let's go ahead and create a quick cylinder. Cylinder is basically going to recreate something like this, where you've got a cylinder oriented in space, and it's going to use the height of it, and what it'll do is it'll push those particles away out from that cylinder shape. And the neat thing about cylinder is that it does not push up or down. There's no radial kind of function other than out from the edges of it. Let's go ahead and color him red. So sphere if you want the full radius, and radial spherical pattern, and cylinder is pretty straightforward there. Now cylinder can use the decays as well. Let's go ahead and take a look here in this top view. If we set it to be 50 units away, so somewhere out in here, it will only kind of push out to that amount, and it fades that effect as it gets away from the center line of this cylinder. But there's also cylinder types have the ability to use the decay too. That applies to cylinder, radial cylinder, and void cylinder. And what that will do is that will actually fade the effect not only from kind of this direction away from the center line, but also from the center along the height of the cylinder. So you can see here that as we scrub forward, all of these particles are being pushed out equally. Well, if we modify this decay too, it's going to affect particles here toward the actual center position and fade it as it moves along the height of the cylinder. So particles up here will get less force being pushed out. Easiest way is just to go ahead and punch in some values, and we'll see that it kind of starts to bring them in there. If we bring this down even more, maybe go 20, what we'll see is that it limits that effect along the height of the cylinder. Let's go ahead and increase the particle count to get a little better view of that. Let's go 5,000. And let's go ahead and set that decay to actually to be, let's say 40. So you can reach it. You can see it reaches up 40 units, and there's kind of an angle effect here where these particles are getting pushed harder, and then the higher up you go in the cylinder, higher and lower all along the center line. As it gets pushed out away from the center along the height, it's going to affect them less. So just kind of a secondary falloff for the cylinder types. Let's go ahead and go back here. Then of course we have the cone type. Cone is going to use this field of view, and it's going to push particles out in a certain, from a position out a certain direction. Again, position, if it's not specified, it's going to be the origin, and direction will be up Z. So we push up that way. You can see we've left the decays on there, so let's go ahead and take that off. Blowing them out of the top. And as you saw, cone can actually use decay 1 as well, so it will limit its effect based on the distance from the origin position. Okay, then we also have Radial Sphere. Radial Sphere is going to actually twist the particles around. Let's give ourselves a little more time to work with too. Let's get out to 300 frames. And as you can see, it's spinning faster here around this origin and closer to the center point. And you can also see in this top view that it's kind of spinning in a counterclockwise fashion. If you want it to spin the opposite way, you're going to have to specify a different direction. Now remember, without a direction specified, we're pointing in positive Z, so 0, 0, 1. So if we want to have them spin in the other direction, we're going to use a 0.3 helper set to -1. And now instead of spinning counterclockwise, it will spin clockwise. Let's go ahead and disconnect that. Let's take a look at the radial cylinder. This is interesting because it affects particles closer to that center line much faster and rotates them around the cylinder, whereas these ones out here, the effect fades off and they spin slower. And again, with these radial types, you can use the decay as well to kind of limit the effect along the distance. So here with cylinder, it's going to limit the distance from the center line of the cylinder. And if you use the decay 2, because we are on a cylinder type, then it will also limit the effect along the height of the cylinder.